All right, this video I want to talk about solving systems of linear equations using the substitution method. Here's our system, x plus 2y equals -1. That's a line. And we have x minus y equals 5. That's a line. These happen to both be in standard form. My first question for you is this system set up for us to use substitution method right now? The correct answer to that question is no, we're not set up for substitution yet. But how can we rewrite the top equation to set this up for substitution method? So this top equation, how can we rewrite this so that we can use substitution? All right, we could rewrite the top equation. You could have said you either solve for y or solve for x. I think on this one it's easier to solve for x. So that's the way I went. So we subtract 2y from both sides and we get this new equation, x equals -2y minus 1. So that is this top equation has been rewritten as x equals -2y minus 1, or also known as x form. And the bottom equation remained the same, x minus y equals 5. So here's my new system. So now this is set up for substitution, right? X equals -2y minus 1. So I'm going to take that, and I'm going to take the -2y minus 1, and I'm going to substitute it in for this x. The reason why we can do that is we know that the point of intersection, x comma y, is the ordered pair that they intersect. And for both equations, x equals x and y equals y at that point of intersection. All right, so the beautiful part of doing this is now you see when I substitute the -2y minus 1 in for x, I replace x with that, I get this, and then it's minus y equals 5. So now I have one variable. So now we can solve for that variable. So we're going to go ahead and go through here and solve it. So I combine like terms, I get -3y minus 1 equals 5. I add 1 to both sides, so plus 1 to get the 6 on the right side. So -3y equals 6. Then I divide both sides by -3, and we get y equals -2. All right. The question for you now is, are we done solving this system of equations? Explain why, yes or no. Hopefully you said no, we are not good to go yet. We need to know what the x is, right? Because we're trying to find a point of intersection, which is x comma y. So a rookie mistake is we stop here at y equals -2. We're not done. So now we go back to our original system, and we can pick either equation, the top or the bottom equation, and we're going to substitute the y, -2, for the y. So I chose the bottom equation here. So I went x minus -2 equals 5. That becomes x plus 2 equals 5. And then we subtract 2 from both sides, and we get x equals 3. Now, is this in the form that I want to see your final answer in? Yes or no? In other words, how do we write our final answer? That's right. We write our final answer as an ordered pair. So our final answer should be parentheses 3 comma -2 parentheses. The ordered pair, that's the point of intersection. X is 3, y is -2. That'll be our final answer. We'll talk a little bit later about how do we check that answer. For now, I want to move on to do this exact same example a different way. This time, I still want to use substitution method, but I want to start by rewriting one of the equations in y form so that we have y equals. So for this one, let's rewrite the bottom equation in y equals. Can you tell me what we get when we rewrite this as y equals, the bottom equation? All right, when we go to rewrite the bottom equation, you subtract x from both sides, right? So then you get -y equals -x plus 5, okay? Then I multiply both sides by -1, or I divide both sides by -1, so all the signs change, so we end up with this y equals 1x minus 5. The top equation, I just brought right on over. So here's my new system of equations. They represent the exact same lines. So now, what can we substitute for? What we're going to substitute for now is this x minus 5. Y equals that. So I'm going to take that x minus 5, and in the other equation, I'm going to replace the y with x minus 5. So now we get x plus 2y, which is going to be 2 times x minus 5, equals the negative 1. So you see the top equation? I just rewrote it right here, but I replaced the y with x minus 5. All right? Then I get x plus 2x minus 10 equals negative 1. What did I do? Distributive property, right? 2 times x, 2 times negative 5. Then we combine like terms here. So I get 3x, and I also added 10 to both sides. Add 10, add 10. So that's how I got the 3x equals 9. And then we divided by 3. So we get x equals 3. All right, next, I take that 3 for x, and I substitute that back into one of the equations. Again, I picked the bottom equation, x minus y equals 5. So we basically took the 3 and went, boop, substitute in for x. All right, so I get 3 minus y equals 5. I subtract 3 from both sides. Negative y equals 2. You got to be real careful right here. People forget the negative y. It's negative 1y. And then I multiply both sides by negative 1. And so we get y equals negative 2. So what's our final answer going to be? Our final answer is 3 comma negative 2. Now, how are we going to check our answer? How do you know if this is correct? Well, we have a couple options. One, we know we could graph it. So I could go in the Desmos, and I could put both those equations in the Desmos, and here's my lines. And then I find the point of intersection is 3, negative 2. Check, we got it right. All right, but you can also check it algebraically. So again, the 3 represents the x, and the negative 2 represents the y. So I substitute that into both equations. So x is 3, so I replace this x with 3. 2 times y, so 2 times negative 2 equals negative 1. Well, let's see what you get. 3 plus, this is what, negative 4 equals negative 1. Yep, negative 1 equals negative 1. All right, how about the other equation, the bottom equation? 3 for the x minus negative 2 equals 5. So then I get 3 plus 2 equals 5. So yeah, that's true. 5 does equal 5. Check. So remember, it has to check for both equations. Your final answer, you should be able to substitute into each equation, and it has to work. Why is that? Because that is the point of intersection. It has to work. Every point on a line makes it a true statement. If you make a little mistake, it's possible, let's say you get a point that's on the red line. Okay, it's on the red line. You substitute into that equation, it works. If you stop there, you think you got it right, you might have made a mistake. Because if you check the blue line equation, you substitute this point you found here into the blue line equation, it's going to come out being false. It will not work. So that's why you need to make sure you're checking both equations to make sure you got it right. Or if you have access to the graphing calculator, by all means, you can just graph the two lines and see if you got the correct ordered pair that we did. Hope that helps. You're going to be working on a number of these problems today.